Okay, we're going to look at our hypothesis testing and make a little change here in steps 2 and 3, something called the p-value method. The other day we looked at our hypothesis testing and we found a critical value here in step number 2, which was a z-score, and we also found a test score here in step number 3, which was also a z-score, and we compared those two. We're going to flip that around and leave our critical value as an area or as an alpha. And we're going to use our test score to find the area under the curve. That area under the curve based on the test score is called a p-value. So I'll give you two choices here as we move forward in steps 2 and 3. We can either memorize these two criteria. If the p-value is less than or equal to alpha, you reject the null. Or if the p-value is greater than alpha, you do not reject the null. Or as you'll see in our example, I'm going to show you how that shading would also help us make that decision whether to reject or not reject the null. Other than that, our 5-step process stays the same. I think I mentioned this when we started this section, but essentially from one day to the next here, steps 2 and 3 are the one we're going to see a little bit of change from day to day. We'll still write our hypotheses and identify a claim in step number 1. We'll either reject or not reject the null in step number 4, and we'll either support or not support our claim in step number 5. It's 2 and 3 where we have a change. Today we're looking at area versus a z-score. So jumping right into our example here, researcher wishes to test the claim that the average age of lifeguards in Ocean City is less than 24 years. Selects a sample of 36 and finds the mean to be 23.7. Population standard deviation is 2 years. Is there evidence to support at 0.05? First of all, let's simply note once again that we have our population standard deviation. That population standard deviation tells me I'm working with table E or our z-scores. As I mentioned, and as we've done already, step number 1 will stay the same. We're taking our null and alternative hypotheses. We're based on a mean of 24 years, a population mean, and it says it's less than 24, so we're less than, greater than or equal to, noting once again that the null has the equal to sign with it, and here our researcher tests the claim that's less than. So the claim is it is less than 24 years. Step number 2 gives us a left-tailed test, remembering that our inequality on the alternative hypothesis tells us what type of test we have. If I put that 0 down the middle, I'm shading on the left-hand side. The only other thing we do with the p-value method in step 2 is simply note that that area is 0.05. From there, we simply move on to calculating our test score. Our test score is going to be 23.7 minus 24. Our standard deviation is 2, and our sample size is 36. That gets me a test score of negative 0.9. Here's where we have another change, or our biggest change. We're going to go to table E and look up the area for negative 0.9. That area is 0.1841. That's that 4-digit number using this as our z-score, as our test value. And since we have a left-tailed test, this 0.1841 is also the area to the left. That makes it our p-value. So as I said, we can take that p-value, which is 0.1841, and we can compare it to alpha. I hope it's obvious that 0.1841 is larger than alpha. So if I slide back up here and look at my two criteria, it says right here that my p-value is larger than alpha. We do not reject the null. I'm allowed to go back down here, and in step number 4, I can simply write that down. Do not reject the null. Again, 0.1841 was our p-value, the area based on our test score. We compared that to alpha, memorized those two criteria. Now, rather than memorize, what I do, or I like to do anyway, I think is easier, is I'm simply going to shade this area over here on my original curve. 0.1841 would be a larger shaded area, so you can see when I shade, my new shading comes into my previously unshaded area, which tells us the same thing from Friday or from a previous work, that anything in the unshaded area tells us to not reject the null. And then once we have not rejected the null, We can go back up here. By not rejecting the null, we're saying the null is true, which means the alternative is false, which means the claim then is also incorrect. So there is not enough evidence to support the claim. So there we are, the first look at the p-value method. Again, memorizing the two criteria or comparing the area, whichever you feel comfortable with. Hopefully that makes sense. We'll do two more, so hopefully two more will sink it in a little bit deeper. We'll move on to our next problem. You can see here, researcher claims the average wind speed in a certain city is 8 miles per hour, sample of 32, has a wind speed of 8.2. The standard deviation of the population is 0.6, alpha is 0.05, use the p-value method. So I underline population standard deviation, which again is table E. Null hypothesis based on a mean of 8 miles per hour. Alternative hypothesis based on a mean of 8 miles per hour. It says the wind speed is 8 miles per hour. That means it's equal to and not equal to. Equal to sign always goes with the null. That's why I wrote it first. The researcher also claims that the average speed is 8 miles per hour. So this is the first example that we've had where the claim has been the null hypothesis. Step number 2, because of that equal to and not equal to, we have a two-tailed test. So when I sketch my curve, I have a shaded area on the left-hand side, but we also have a shaded area on the right-hand side. Which means if alpha is the area in both tails together, the area in each individual tail is 0.025. 0.05 in total, so divide that in half, the area in each tail. Step number 3, we will calculate our test value. 8.2 is our sample mean minus our population mean of 8. 0.6 is our standard deviation, and our sample size is 32. Gives me a z-score of 1.89. Going to our table, we look up 1.89. We find a value of 0.9706. Now, 1.89 would be a z-score over in this area here. That 0.9706 measures the area to the left. You can see on the right-hand side, our positive score, we want the area to the right. To find that area, I would subtract from 1, so I get 0.0294. So that's the area in the right side of the curve. If we want to go full bore with the p-value method here, we would take that number and we would double it to get our actual p-value. I'm going to multiply that by 2 and get 0.0588. That number represents our p-value. So with our p-value, we're comparing that p-value 0.0588 with the alpha of 0.05. Here, 0.0588 is slightly larger than 0.05. So one way, if we memorize the criteria, p-value larger than alpha, we do not reject the null. If you want to use the shading idea, I'm just going to shade the smaller part of that, so 0.0294. If I were to shade, it would be slightly larger than 0.025, so I'd come into the previously unshaded area, which again from our work the other day also would tell us to not reject the null. And finally here, to finish things off, since we did not reject the null, and the null is our claim, the null is true, which means the claim is true, so there is enough evidence to support our claim. There's a two-tailed test with our p-value method. We have one last example. We can zip through this one fairly quickly. Mean GPA for one college is 2.45. Standard deviation is 0.69. I'm going to highlight that right now. That's overall information. So even though it's not spelled out, that is a population standard deviation. Population standard deviation is table E. Engineering professor believes that the engineering majors have a higher GPA. Sample of 30, a GPA 2.65, test at the 0.01 level. As always, we will start with our null hypothesis based on the population mean of 2.45 and our alternative based on a population mean of 2.45. He says higher, which is greater than, less than or equal to, null always has the equal to part, and over here is our claim. So you can see here we have a right-tailed test because of the greater than symbol here. Over here our shaded area is 0.01. That's all we do in step number 2 with our p-value method. Z-score is 2.65 minus 2.45. 0.69 over the square root of 30. That value, that z-score, test score, is 1.59. Since we're finding the p-value, we look up 1.59 in the table. That number is 0.9429. 1.59 would be a z-score somewhere in here. The area to the left of that is 0.9429, but we have a right-tailed test, so we want the area to the right. We'll subtract that from 1 and get 0.0571. That number, since it's a single-tailed test, is our p-value. So once again, if we memorize the criteria, 0.0571 is our p-value, 0.01 is our alpha, 0.05 is larger than 0.071, which tells me to do not reject the null. I'm going to continue the shading idea as well. With the shaded area, 0.0571 is going to be substantially larger than 0.01. You can see our new shaded area comes in the previously unshaded part, which again should tell us to not reject the null. And finally, since we did not reject the null, let's go back to blue here. We did not reject it, so this is true, which means this is false, which means the claim is also false, or there is not enough evidence to support the claim. And that encompasses our p-value method.